Hello and welcome everyone. This is Mohammad Inzamam from Saimedha Ecet Coaching Center, Koti, Hyderabad. Saimedha Koti, Hyderabad is providing free of cost YouTube video lectures for previous Ecet examination questions from the effective faculties of Saimedha Koti, Hyderabad. My dear students, in these video lectures every single day for all the branches EC, EEE, Mechanical, Civil and Computers. For all the branches every single day we are updating PYQs, previous Ecet examination questions. So what are you waiting for, guys? Subscribe the channel and press the bell icon to be notified for the further more updates. Daily update చేస్తున్నాం. My dear students, in the era of where people are making everything as a business, Saimedha Koti Hyderabad is giving the coaching for online Ecet 2024-2025, offline Ecet 2024-2025 కి మనం కోచింగ్ అనేది న్యూ అడ్మిషన్ న్యూ బ్యాచెస్ అనేది ఆల్రెడీ స్టార్ట్ అయిపోయినాయి. ఈ రోజుల్లో where 10th class admissions are going to be for month, effective faculties లో home tuitions కూడా పర్ మంత్ ఎవరైనా సరే 1000 రూపీస్ కంటే తక్కువ అంటే ఛార్జ్ చేయడం చాలా కష్టం. ఎఫెక్టివ్ ఫ్యాకల్టీస్, రెప్యూటెడ్ ఇన్స్టిట్యూట్స్ లో రెప్యూటెడ్ ఎక్స్పీరియన్స్డ్ ఉన్న ఫ్యాకల్టీ మెంబర్స్ తో మీరు 10th క్లాస్ హోమ్ ట్యూషన్స్ తీసుకోవాలన్నా సరే పర్ మంత్ దే విల్ బి డెఫినెట్లీ ఛార్జింగ్ మినిమం 1000 రూపీస్. అలాంటిది in and around for 1 year you will be getting a payment of around how much? 12,000. For SSC home tuition itself, if you are paying 12,000, guys, Saimedha Koti Hyderabad is providing 1.5 year coaching, 2 years coaching, 3 years coaching. Saimedha Koti Hyderabad lo coaching anedi first year diploma nunchi start అయిపోయినాయి, second year diploma students ki start అయిపోయినాయి, third year diploma students ki start అయిపోయినాయి. 3 years course ఉంటది, 2 years course ఉంటది, 1 year course ఉంటది. అలాంటిది టోటల్ కోర్సెస్ కూడా ఎప్పుడు మన దగ్గర ఫీజు అనేది 10,000 దాటలేదు. అందులో కూడా మళ్ళీ మెరిట్ పెట్టి పర్సెంటేజెస్ వైజ్ కన్సెషన్స్ పెట్టి ఎకనామికల్లీ బ్యాక్వర్డ్ ఎవరైతే ఉంటారో వాళ్ళని ఎంకరేజ్ చేయాలనే ఉద్దేశంతో మినిమం ఫీజెస్ తో మాక్సిమం కన్సెషన్స్ తో సాయిమేధ కోటి హైదరాబాద్ ఈస్ ప్రొవైడింగ్ ఎవ్రీ ఇయర్ కోచింగ్. రిజల్ట్స్ విషయానికి వస్తే యు నో ఇట్ గైస్, ఎవ్రీ సింగిల్ ఇయర్ టాప్ 5 బ్రాంచెస్ లో స్టేట్ ఫస్ట్ ర్యాంక్స్ తో పాటుగా మాక్సిమం ర్యాంక్స్ వాస్ సెక్యూర్డ్ బై సాయిమేధ కోటి హైదరాబాద్ ఓన్లీ. So my dear students, what are you waiting for? Ecet 2024, Ecet 2025, Ecet 2026 coaching has been started in the Saimedha Koti Hyderabad. ఎఫెక్టివ్ కోచింగ్ ఎక్కడైనా ఉంది, మనకు ఎక్స్పర్టైజ్డ్ ఫ్యాకల్టీస్ నుంచి ఎక్కడైనా కోచింగ్ ఉంది, డిజిటల్లీ రికార్డెడ్ వీడియో క్లాసెస్ ఒక సిస్టమాటిక్ ప్యాటర్న్ లో కోచింగ్ వీఆర్ ప్రొవైడింగ్ బోత్ ఆన్లైన్ అండ్ యాజ్ వెల్ యాజ్ ఆఫ్లైన్. సో వాట్ ఆర్ యూ వెయిటింగ్ ఫర్, గైస్? Download the app saimedha.in and press the bell icon to be notified for the every updates. Every single day we are going to be updating in the YouTube channel. Subscribe the channel, press the bell icon to be notified, download the app saimedha.in and scrolling on the mobile numbers ki contact journey and join now in Saimedha Koti Hyderabad. At the end of the video I'll come back one more time for some more information. Till then, guys, watch the video now.
Let us solve question number 7. In a differential compound generator, the series field turns are provided on armature, commutator, interpoles and main poles. So series field winding and shunt field winding turns are provided on the main field poles only always. Suppose we have so this one is the main field poles. Okay, for example this one is the north pole, assume as a nut. So field winding is placed on the pole shoe, okay, this pole core, okay, as shown in this figure. So now this one is the suppose series field winding and this is and shunt field winding. So now these are the shunt field windings. So now this is the series field winding turns and this part is the shunt field winding turns. The shunt field winding. So always which are placed on this one is the one pole. This one is the pole shoe. Pole shoe here and this is the pole core. Pole core of the machine. The field winding turns are placed on the pole core only, but not on the armature, commutator and the interpoles. So option that 4 is correct for this question. And next one, question number 8. The EMF induced in the armature of the DC shunt generator is at 600 volts. Armature resistance is 0.1 ohms and if the armature current is the 200 amps, the terminal voltage will be option 1 640 volts and option 2 620 volts and option 3 600 volts and option 4 580 volts. So given generator is a DC shunt generator. So this one is the DC shunt generator. So now first draw the diagram to answer this type of the questions. So DC shunt generator means this one is the armature, assume positive group of the brushes and the negative group of the brushes. So there is a field winding we have. So armature and the field winding. So field winding is connected across the armature, and this is connected to the load terminals. So now this is the generated voltage easy, and armature RA, and this current you can say that armature current and shunt field current ISH and the load current IL. So load terminal voltage VT here. So now we require by KVL, by applying the KVL equation, so we can get this terminal voltage. So by KVL equations, this KVL equation, just the voltage rises are equal to voltage drops. So EZ is equal to the VT plus the IA RA, VT plus IA RA. So where IA is equal to, so IL plus ISH value. So this, but here mentioned in this question directly. So from here we can get ET is equal to EZ minus the IA RA. So this is the equation we require. So now what is the given data in this question? So given that, so this is the shunt generator, generated EMF, EZ is equal to 600 volts. So this one is the EZ is given, and also armature resistance RA is equal to 0.1 ohms, and armature current IA is equal to the 200 amps. Now we require the terminal voltage of the generator. So VT1. So EZ is equal to 600 volts, RA is equal to 0.1 ohms, IA is equal to 200 ohms, VT is required. Just substitute here the VT is equal to, the VT is a EZ value is the 600 volts. This value is equal to 600. The minus, what is the armature current? 200 amps. Now this is equal to 200 minus 0.1. So now VT is equal to 600. The minus 0.1 means minus 20. So therefore VT is equal to 580 volts. So now here answer for this question, the 580 volts is the right answer. And next one, let us solve question number 9. In a 8-pole, the lab-wound DC generator is supplying the 295 amps to the load. Lab-wound DC generator supplying 295. The field current of the generator is 5 amps. The current per parallel path, is, so here the DC generator is given. This is, so unless otherwise specially mentioned, DC generator in the sense the separately excited generators. This is a, unless, very important point. So option 1 is a 300 amps, option 2 is a 37.5 amps, and option 3 is a 150 amps, and it is a 100 amps. So what is the given data in this question? The given that the number of the poles is equal to 8 number of the poles, and lap wound the DC generators. The lap wound DC generator means number of the parallel paths. The A is equal to number of the poles, that is equal to 8 number of the parallel paths, and the supplies the current of, this the supply, the current means load current IL is equal to, so this IL is equal to 295 amps, and also field current is mentioned, IF is equal to the 5 amps. Now the current per parallel path is required, current, so per path. So now also mention here the DC generator, this is the DC generator. So whether it is, we don't know that whether series generator, shunt generator, compound generator, unless otherwise specially mentioned, the DC generator in the sense separately excited DC generator. So now DC generator means here, so unless, note this part, unless otherwise, otherwise specially mentioned that the DC generator, DC generator in the sense separately excited. So this is the separately excited DC generators, separately excited DC generator. So in separately excited DC generator means this is the field winding. The field winding we have, it is excited with the DC supply, and this current is a IF, and there is a armature. Assume as this one is the armature. So now here this is the load we have. So now load 10. So now this is the generated voltage EZ, and this rotated by the prime mover, and this current I can say that armature current, and this current is the load current. So now from here what I conclude, armature current is equal to, so armature current is equal to IL, so in separated is excited generator, so that is equal to 295 amps. Okay, this one is the 295, but we required current per path is a required, current per parallel path. Okay, this parallel path. So now this value is equal to armature current divided by A. So what is the value of A? A is equal to 8. So number of the parallel paths, okay, 295 the divided by 8. So by simplification, so we will get 37.5 amps. So answer for this question, 37.5 amps is the right answer. Okay, this one is the 37 point. So don't don't add these two. Okay, why? Because it is not a shunt generator. If it is shunt generator, we can get the 300 amps. But here mention that only DC generators, so that we need to consider that the separately excited DC generators. Okay, got it? And next one, let us solve question number 10. If the field circuit resistance of the DC shunt generator exceeds the critical value, generator option 1 fails to build up of very high voltage, exceeds its current capacity, and option 4 produces high power. So if the field winding resistance, the resistance of the field winding is greater than the critical value, then the generator fails to build up of the voltage. So what is the mean by critical resistance, or the resistance of the field winding, the above which the generator fails to build up of the voltage. So now answer for this question, option 1 is correct. And next one, let us solve question number 11. The field winding of a self-excited DC generator is excited by the DC and option 1 the AC, and both DC and AC and its own current. The field winding of the self-excited DC generator excited by its own armature current. So option the 4 is correct for this question. And next one, question number 12. The voltage regulation of the DC generator is good at full load implies that the generator, the shunt generator, differential compound, cumulative compound, and so now series connected generator. So voltage regulation is equal to it is a percentage voltage regulation is the VNL minus V full load divided by V full load voltage, so multiplied by 100. So no load voltage is a EZ0, okay, EZ, the generated voltage under no load condition. The full load voltage is the terminal voltage, okay, divided by terminal voltage multiplied by 100. So this VZ0 is a no load generated voltage. The VT is the terminal voltage of the generator. The VT is the terminal voltage of the generator. So in cumulative compound generator, so there is a so cumulative compound generator can be operated. So based on okay, compounding, okay, this is the based on the compounding. So compounding means adjustment of the terminal voltage. Compounding is a adjustment of, okay, this adjustment of the terminal voltage, okay, VT. So is the cumulative compound generator, cumulative compound, okay, generators is classified, okay, this is the classified, okay, such as first one over compound generators, and second one is a plot compound generators. So and third one is a under compound generators. So over compound means terminal voltage is greater than the no load generated voltage. Now terminal voltage is almost equal to the no load generated voltage. In under compound generator, terminal voltage is the less than the no load generated volt. So cumulative compound generator has good voltage regulation because of adjustment of the terminal voltage. So terminal voltage can be obtained more than the no load generated voltage, by using over compound the generators. The terminal voltage is almost equal to the no load generated voltage by using flat compound generators. Similarly, the terminal voltage can be obtained less than the no load generated voltage by using over compound generators, so that the voltage regulation of the DC generator is good at full load implies that the generator must be the cumulative compound generators. So that answer for this question option the 3 is a correct. And next one, question number 13. In which of the following DC generators the terminal voltage increases first and then decreases with the load current? So under compound, separately excited shunt generator and the series generator. So DC series generator cannot build up of voltage under no load condition, but in order to build up of voltage in the DC series generator, the load must be connected. Suppose if the load terminal voltage characteristics here, the load voltage characteristics, this one is the VT and is also the directly proportional to the generated voltage. Now this one is the load current IL. So then what will happen? As a load current increases, okay, this it produces a very small amount of voltage due to the residual flux. So now this one is a increases and then after okay decreases. Now this is a okay initially increasing then decreasing. So this is the only characteristics for the series generators only. So I repeat once again, listen. The DC series generator cannot build up of voltage under no load condition, but in order to build up of voltage in the DC series generator, the load must be connected. As a load current increases, the generated voltage of the generator increases initially, then after the decreases. So which type of the characteristics here? The series generator characteristics is a correct answer for this question. So now this is the option 4 is correct, okay. And next one, the question number 14. The field current of a shunt excited DC generator is the proportional to the terminal voltage, proportional to the armature current and proportional to the load current independent of the terminal voltage. So field in the DC shunt generator, okay, DC the in case of the DC shunt generator, so this is how do we get the field current? So shunt field current ISH is equal to the VT by RSH, VT by R. So now in the DC shunt generator, shunt field current is equal to terminal voltage divided by the shunt field resistance. VT is the terminal voltage, RS is the shunt field resistance value. So it is a constant, some finite value, okay, this one constant or some or so that is a finite okay value. So suppose it is equal to the 100 ohms, 200 ohms and so on, some finite value. So now therefore ISH is a directly proportional to the terminal voltage of the generators. So now this one is the field current of the shunt excited generator is a proportional to the terminal voltage. So option 1 is correct for this question. And next one, let us solve question number 15. A series generator is running in its normal speed and output is a open circuit. The terminal voltage developed is. So now under the series generator's point of what are the characteristics? So now this one is the generated voltage EZ and this one is the field current IF. So now this is the OCC characteristics of the series generators, okay, this one. So under no load condition, okay, under no load condition, so it develop the very small amount of the voltage, okay, this one is. So DC voltage, so due to okay the residual flux, so that means in general the DC series generator cannot build up of the voltage under no load condition, but it generates very small amount of the voltage. It is in the order of 5 to okay 10 volts. So due to the residual flux. So I repeat once again, listen. So DC series generator cannot build up of the voltage under no load condition, but it generates very small amount of voltage in the order of the 5 to 10 volts due to the residual flux. So answer for this question, rated voltage, 0 voltage, the small voltage and double the rated voltage. So which answer is correct? So option the 3 is the correct. So in these options, if there is no small voltage, what is the answer for this question? 0 voltage. Sometimes options are given. Option A 0 volts and option B 50 volts and option C 100 volts and option D 200 volts. Like these are the options. So now if here 50 volts is given, what is the answer here? The 0 volts is the correct. Suppose same question, option A 0 volts, option B 5 volts and option C 100 volts and option D 200 volts. Now what is the answer for this question? 0 is not correct answer. So option for this question is the 5 volts. Why? Because the DC series generator under no load condition that generates the small amount of the voltage, okay, small amount of voltage, but it cannot build up of voltage under no loaded conditions. Got it? So answer for this question, option the 3 is the correct. Got it?
So thank you very much guys for watching this video till the end. Definitely this video has been improvised your subject knowledge and definitely given you an idea about how the previous Ecet examination question is getting up here. Again one more time guys, ee video ni meeru nachite kachithanga like cheyandi, share cheyandi, subscribe cheyandi and press the bell icon to be notified for the further more updates guys. అడ్మిషన్స్ అనేది ఆల్రెడీ స్టార్ట్ అయిపోయినాయి. ఈసెట్ 2024, ఈసెట్ 2025, ఈసెట్ 2026 ఫస్ట్ ఇయర్ వాళ్ళకి, సెకండ్ ఇయర్ వాళ్ళకి, థర్డ్ ఇయర్ వాళ్ళకి ఆల్రెడీ ఈసెట్ కోచింగ్ అనేది ఆన్లైన్ కోచింగ్ అండ్ ఆఫ్లైన్ కోచింగ్ new batches is going to be started guys. So my dear students, what are you waiting for? Download the app saimedha.in. మీకు ఏ డౌట్స్ ఉన్నా సరే మన స్క్రోలింగ్ లో ఉన్న మొబైల్ నంబర్స్ కి కాంటాక్ట్ చేయండి. Join now in Saimedha Koti, Hyderabad. Thank you very much. This is Mohammad Inzamam signing off.